And welcome to RockSim Live. My name is Tim Van Milligan, and this is RockSim Live, where we answer your questions about rocketry and about RockSim and RockSim Pro and the launch visualizer. Today is September 26, 2025, and if you're watching, you're in the right spot. This is where you can ask your questions about RockSim and RockSim Pro and the launch visualizer. I do have the chat going, so go ahead and type those questions into the chat and we'll be happy to answer them. Yeah, there's a whole bunch of people here already. We've got Friar Pablo from Western Iowa. He calls his house the launch domain Rocketry Clubhouse. We have Wheelock's World here. And Terry says that Tim is always late. Michelle never was. It's 2 o'clock Mountain Time, and I'm on time. I'm here. Anyway, as you can see, I got the same situation I had last week. My laptop computer is just getting old, and it's slow, and the fan runs the whole time, so it's just kind of chugging through things, because when you're trying to do a live stream, it takes up a lot of CPU usage. So I've got a newer computer here I stole from our graphic arts office, and it's much faster, and it doesn't get hot, and yeah, it's so fast. So yeah, so we got the first question is build the new SpaceX lunar stubby rocket. And I don't think I know what that one looks like, so I'm not sure if I can do it. Give me a RockSim question. So let me go to my computer screen here. So if you are brand new to us, our web address is apogeerockets.com. And that's where you'll find RockSim, RockSim Pro, and the launch visualizer. So if you just kind of go to the home page here, and if you scroll down, it says free RockSim training every week. That's what we're doing right now. We're doing that training. And if you click on that, it will take you to our archives. And we're on episode 212, so we're a little bit behind in updating the archives. But this is all the topics that we have talked about previously. And if you want to revisit those topics, you can just click on the timestamp here and it will take you to the correct YouTube where you can watch those. So there's a lot of really good information there. So feel free to click on those. But if you have an immediate question, go ahead and put that in the chat. And I'll be happy to try to add those to my list here. If you want a copy of RockSim, go to How To and Guides, and then come down here to Software, and then you can, right here it says RockSim 11 free trial. You can get it right there. You'll just enter your name and email and where you're from, and use that little CAPTCHA, and then we'll send you a confirmation link, and then you can get downloading. If you want to learn more about it, like this is your first time using it, again, go down to Software from How To and Guides. Click on that, go to the RockSim video tutorials. That's where I suggest you start. So that's where we've created a whole series of tutorials to kind of get you going as fast as possible. Man, my voice is going all of a sudden. So that's kind of like the gist of things. We have Friar Pablo asks, what's the best method to add materials that aren't commonly sold as rocket materials? I have some cardboard tubing that I want to model in RockSim. Okay, we can do that. I am in RockSim Pro, but RockSim is identical. I'm kind of using RockSim Pro today because eventually we're going to try to get you all to switch over. And we've got this special incentive coming up that will make it like almost a a no-brainer to do it. um, it yeah, it doesn't cost anything. So what you're going to do if you want to add a new material, you go to the rocket menu here at the top, click on that, come down here to edit database, and you want to go to materials. And so you'll do that. And then this is the database of all the materials that are in RockSim. Okay, so you can see it's kind of like a spreadsheet, but there's only a few important columns here, and they're the ones on the left. So there is one already called cardboard. But if you have a different cardboard, you'll probably want to make a separate one. So what you'll do is you'll come down here to the bottom where it says add new. You'll click on that. And what happens is it made a new entry at the very, very, very bottom. So you can call it, the new name. Cardboard 2. Since I already have a cardboard, I'm going to call it cardboard 2. And then you need to find out the density of the material. And this is the hard part because you either have to do some math or you have to look it up somewhere. Basically you need to find the volume of the material object that you have. And then finding the volume. So finding the volume of a tube is finding the volume of a cylinder and then subtracting out the volume of the inside cylinder that's not there. And that gives you a total volume. And then you're going to weigh it. So you're going to have units. So you can either have English units or metric units. So in English, it's pounds per cubic foot. In metric, it could be kilograms per meter cubed or grams per centimeter cubed. So it depends on what units you're using. If you don't know what it is, like I said, up here we have a different cardboard, and this one is 43 pounds per cubic foot. So maybe this new one, we'll call it pounds per cubic foot, and then we'll put in, I don't know, maybe it's lighter weight. So maybe it's 40 pounds per cubic foot. And then those are fixed dimensions. So fixed dimensions are kind of like, a tube could be a fixed dimension. But here's what you're dealing with. Something that has a constant thickness, kind of like a sheet of plastic. So, or something that has a diameter like a log. And then you're going to just find out the length of it. But if you don't know it, just select none, and then it's just this density right here. And then you're going to use, what units you're using, and we're going to use inches. And then just leave that 0. And then you need to select this column right here. So these are check boxes. And if you check it, it turns into a 1. If you don't check it, it's a 0. So when you check it, it means that I can use this for rocketry. So basically, you can turn things on and off in your database right here. So like these materials right here, I have titanium. I have that turned off. So that's not going to show up when I'm building a tube or something. It's only when it's checked, when it's a 1, that you'll see it listed. So I'm going to say, yep, I can use this for rocketry. And then you're going to select which components you can use that material for. So a cardboard tube on a fin, on a body tube, yes, I can use that would make sense. For a fin, you might, so you can add it there. For a launch lug, maybe. For a shock cord, am I going to use cardboard for a shock cord? And the answer is probably no. So you're not going to check that one. Nose cone, it's possible. So you can check that one. Are you going to use it for a parachute? No. So we're going to leave that one unchecked. And you just go through these. You know, I'm not going to use it for parachute. I won't for use a streamer. Transition, maybe. A ring, maybe. Bulkhead, maybe. Engine block, maybe. Okay, and then you clicked OK. And so now you've added a material into the database. Now, how do you build something with it? Well, then you come over here to the Rocket Design Components tab, and we're going to start building a rocket. Actually, what you'll do is you just kind of work across these tabs. So our first one, we need a rocket name under the attributes. So we'll call it Cardboard 2 Rocket. And I'm just going to leave everything else by default. And then I'm going to go over to the Rocket Design Components tab. And then we're going to start adding parts to my new rocket. So for this nose cone, I don't know, let's go with a PNC 30. So that's a plastic nose cone. But if I want to change it, so basically it opens it up into here. Oh, so why did I do that? Don't do that. I wanted just to make it a little bit larger here. So if I come here to materials and I look in the materials database, and if I look down here at the bottom, and it might be off of your screen, and it is. Let's see if I can get it up to here. Yeah. No, it's the one below cardstock. And so if I go down one more, it says Cardboard 2. And if I select it, you'll see it. See, now it says Cardboard 2 up there. So it is in the database. So now it's based on that density of material. See, RockSim is calculating the volume of this nose cone based on its shape. And then it's going to calculate a mass for that nose cone. So if you like it, then you click OK. So now we have a nose cone that's made out of Cardboard 2. So now if I want to add a new body tube, again, that was a 33 millimeter. So click OK. So there's the tube. Let me make this bigger for you. And if I go here to material, right now it's set to polycarbonate. But if I click on it and I come down, there it is, Cardboard 2. So there's our new material from the database. And then you just click OK. So this component mass is now 19.371 grams when it's Cardboard 2. When I use the regular cardboard, it went up to 20 grams because now this, remember we said this new one was going to be less dense, so it was going to be lighter weight. So that's to be expected. So basically everything's working. So hopefully that answered your question on how do you add a material to the database. Now, what your question you probably should have asked was how do you add a component to the database? Because it's already a cardboard tube. It just has different diameters than what's already in your database. So here's how you do it. So I can go, let's see. There might be multiple ways to do it. Let me check here. So under the Rocket menu, go to Edit Database, and we want to come down to Body Tubes. Okay, so again, so here is another spreadsheet. And again, down here in the bottom, there's an Add New button. So you can click on it. It always puts it at the very bottom, and it's kind of hidden. And there's nothing in it, so it doesn't look like there's anything there. But this is where you're going to add your new tube. So you could say, my new cardboard tube. And you can give it a part number, or you could leave it blank. You can give it a description, or you could leave it blank. Those are optional. I'm going to select the units, and then you can select the inside and outside diameter. So I'm going to make my outside diameter 1.0. 326, and then the, oh, that's the, should have been the 1.285, whoops, and 1.325. And you give it a length, and you can say maybe it's 18 inches long. Maybe you got it from the store and it was 24 inches long, so you would type in that number there. Then you type in what material it is and say this is going to be cardboard, the normal cardboard that's already in the database. Then you can say what units you're going to be. And then if you know the mass, you can put that in there. And then RockSim is going to figure it out. Say it weighed 40 grams. And then you click OK. So now we've added a tube to the database. So that was one way to do it. Okay, that was the first way. So if I wanted to use it, I would select a body tube, and then I want to go through into the database and what did we call it? My cardboard tube. Let's see if it's ever at the very bottom. There it is. At the very, very bottom is my new cardboard tube. I click OK. It adds the tube. Remember, it was 24 inches long, and it calculated the mass based on the dimensions that you put in. So if you measured the inside diameter, the outside diameter, and you got a mass, and you put that into the database like I just showed you, it's going to calculate the density, and then from that, or it knows the density from the cardboard, and it's going to give you the mass right there. So that's the other way to, that's okay. So that's the first way and how to use it. Let's click OK. So now another way to do it is let's add a body tube. And this time we're not going to select from the database. We're going to cancel out of the database. And now I did it again. We're going to select the outside diameter. Again, you got to have to measure it, 1.325. And then you have to know the inside diameter. I don't know, remember what it was 1.285 was what I think I had. And then you have to say the length. And I'm just going to guess at it right there. And then when you, let's see if I make it 24 inches long. Yeah, and it's made out of cardboard. And there it is. But now it's still not in the database. So we just created a tube as we were designing a rocket. Now to put it into the database, you can come up here to database, and then you can say save to database. So now you need to give it a new name. Second new cardboard tube is the name. And you can give it a part number if you want, like 000. Description, say it's like I store bought from, I don't know, Walmart is the part description. And then hit save to database. And what it did was it copied all that information from here and it brought it down into here. And this is kind of like your last chance to change things. And then you'll just click OK. And so now it's been saved into the database. So if I click OK, and if I add another body tube and add another body tube there, and then now it's looking in the database. And if we look through the database, and I bet you it's at the very bottom, if we scroll all the way down, maybe it didn't put it there. What do we call it? Second new cardboard tube. There it is. It was at the very top. Second new cardboard tube. And again, it has the description that we bought it from Walmart. And then we click OK. And now we have the third tube in there. So there's two ways of adding tubes into your database. But there's only one way to add a material to your database. And that's by going up to the rocket menu and then doing the edit database. Okay. Save your changes? No. All right. Okay, let's see if we got more questions here. All right, so Pablo, Friar Pablo says it's a 40-inch long, 4-inch diameter with a 0.125 wall thickness. Yeah, so basically you got to weigh it, and then you can, I would probably use the second method of creating a body tube, adding a body tube, canceling out of the database, and you said it's 4 inches in diameter. But you need to know the wall thickness, or the wall thickness, but you need to know the inside diameter. So to get the inside diameter from the wall thickness, you multiply it times 2, because you got thickness on both sides, so that's 1/4 inch. So, and then you subtract it from the outside diameter. So you subtract that, and that's going to be 3.75 inches. And then the length was 40 inches long. And you can see there's our new tube, and select the material, and that's basically how you add it. And then you go to database, save to database, and like I just showed you. Okay. DK says, Tim, after I use the rule of thumb of thrust equals 5 times the weight and a CP minus CG divided by the diameter is greater than 1, do I need to know anything else to ensure stability as the rocket leaves the launch rod? Okay, so let's cancel out of that. Save your changes. No. So let's open up a design. So go here to File, Open. Let's go with the Peregrine. Click Open. Do you want to save this other changes? And I'm going to say no. I don't care about those. Okay, so here's a Peregrine. And his first question is, he knows the relationship between the center of gravity and the center of pressure. So you want to check stability. In order to check stability, you have to put the rocket motor in it, because we need to know the weight of the rocket plus the motor. So to load a motor in, come up here to this icon, and basically it's kind of like the bottom of a rocket. So you see the tube and the fins, and then there's 2 arrows pointing downwards towards a disc, and that's our blast deflector. So that's prepare for launch. So you click on that, and then this brings up the motor selection screen. So what we're looking at is the bottom of the rocket, and it's highlighted. I don't know if you can see the color, but it's highlighted. That's the motor mount. And it tells us right here what the diameter is. So we're going to come down here to choose engine. And then from the list, we can choose a motor that will fit. And all these are 38 millimeters in diameter. And and under the diameter filter, it says only show engines that match the motor diameter. So this is why it's only displaying 38 millimeter motors. So if you wanted to show them all, choose show all engines, and then you're going to get a whole bunch more. There's a lot more. There's a couple hundred more. But now it's a little bit confusing because you got a mixture of different diameters. So you want to, this is by default, we have show only the motors that match the motor mount diameter. So leave that. And then you have a 38 millimeter motors, and then you can just select from one of the motors in the list. And it really doesn't matter for your first one. I'm going to choose an H130, and I'll choose a 14-second delay, and then click OK. So when we do that, I'm going to click OK here. So it showed the motor in there. So now you can see there's a brown motor in here. And what happened was when we loaded that motor, the CG shifted backwards because now we have more weight in the back. So now this is the true distance between the center of gravity, which is this symbol right here, and the center of pressure. So now the question is this rocket statically stable, and is it going to be safe to launch? And we can check static stability because the center of gravity is in front of the center of pressure. That is, by definition, a stable rocket. When it's unstable, the center of gravity, this symbol right here, is going to be behind the center of pressure. We don't want that. That's definitely what we don't want. So the first thing you want to check is the center of gravity forward of that? And then, by how far? And we use calibers. So calibers is kind of like a dimensionless term. It doesn't have a dimension, but what it means is the distance here in inches or centimeters divided by the diameter. So inches divided by inches, the inches cancel out. So then it tells us just a ratio of the distance to the diameter. And that ratio is right here. And this is called the margin, the static margin. And ideally, we want that number greater than 1. Sometimes it can be under 1. And if it's greater than 1, it's okay. It just means it's going to be more stable. And we can look at more stable later, but this is actually pretty good right here. Now we want to launch it, and we want to find out, is it taking off fast enough? And why do we want to know that? Because our rockets are not guided. It means the rocket motor doesn't gimbal. It doesn't move around. Like a motorboat. The motor can swing back and forth. That's called a gimbal, and that changes the direction of the rocket. Our rockets are unguided. They can't change the direction of the thrust. So because of that, the only thing that's stabilizing the rocket is the fins. And the fins need air flowing over them to create forces. And there's 4 forces acting on a rocket. There's lift and drag, and those are aerodynamic forces, and those need air flowing over the rocket. And the other 2 forces are gravity, which, because it has mass, gravity is going to be pulling down on it. And then the 4th force is thrust. And so what we need to make certain is that we have enough lift and drag to make sure that rocket stays stable. And what he was mentioning is one of the common criteria that people use is the thrust to weight ratio. Is the thrust 5 times greater than the weight of the rocket? This is not my personal choice, but I know a lot of people use it because it's a simple rule of thumb. But since you have RockSim, there's a better way of doing it. So what you're going to do is you're going to perform a launch. So we're going to come up here to prepare for flight again. And so we've already got the rocket motor loaded. Then we're going to start changing a couple of things. So the flight events is when the parachute comes out of the rocket. And this rocket, we can tell it has 2 parachutes in it. It's got a 48-inch parachute and another one, which I don't know the size, but I'm assuming it's set up for dual deployment, so that this is probably a smaller parachute. So I'm going to say for the smaller parachute, no event. And under the big parachute, I'm going to say let's deploy that parachute at maximum ejection delay. And our ejection delay, if we come over here, is set at 14 seconds. So 14 seconds after motor burnout, which is not the same as 14 seconds after liftoff, because the motor burns for a little short period of time. So after 14 seconds after motor burnout, the ejection delay is going to push the parachute out. And we don't know if that's too long or too short. Not yet. This is why we have RockSim, so we can find out. So now we're going to look at the starting state. So this launch guide length is the launch pad, the launch rod. How long is that? And since this is a big rocket, we're going to assume it's going to be an 8-foot long. So, you can come over here to feet and say 8 feet, and then hit the tab. And then what is the launch angle? So are we launching straight up, or at an angle. Most people launch pretty straight up or within a couple of degrees. The azimuth angle is a compass direction. So north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 or minus 90. So we're a little bit, you can see if this is a compass here, west is over here somewhere, right? So we're going to be like southwest. This is the direction. And then just leave everything else alone. And then under launch simulation controls, just leave that alone. It's set up by default to work fine. And then under launch conditions, we have to choose where we're launching from. This is set for an altitude of 143 feet. I'm not exactly sure where this launch site is, but you can choose a launch site. And here are many of the NAR and Tripoli clubs. You can see the organization right here says NAR. And if I go down further, there's some Tripoli ones. And you can search for your launch site. I'm just trying to think of a name. Houston. There's nothing Houston. Huntsville. Okay, we'll use Huntsville. Click OK. So now we're going to be launching at the Huntsville Area Rocketry Association, site number 2. Wind table is how much wind is blowing across during the rocket and the direction it's coming from. And so right now I have from the direction of 270, and remember I said 270 was west. So the wind is coming from the west at 8 miles an hour. And I have a table here, and at 0 feet above sea level, it's at 270 degrees, so it's coming west at sea level. And then at 18,000 feet, it's also coming west, from the west at 8 miles an hour. So essentially, at all altitudes from sea level up to 18,000 feet, we got an 8 mile an hour wind blowing from the west. Remember, if we go back here, our altitude is 148 feet above sea level. So, and this says 0. So basically, we're fine. We got 8 miles an hour. And then I'm going to hit, I can either hit launch or flight profile. I'm just going to hit launch for right now, and I'll come back and we'll hit flight profile in just a second. So it just ran the simulation, and then it's going to tell us some information about this launch. So here was the H-130 that we picked. Engine diameters here. It's got a parachute here with an arrow pointing down. And that means that the rocket was coming downwards when the parachute came out. If the arrow points up, the rocket was moving up when a parachute came out. And our altitude at deployment was 499 feet, just about 500 feet off the ground. Our maximum altitude was 929 feet. So it came down, over 400 feet before it deployed its parachute, or about 400 feet. The maximum velocity was 157 miles per hour. And the optimal delay is 6.3 seconds, 33 seconds. So that is what we should have selected for the delay. So our delay was 14 seconds and the optimal was 6.33. So that would pop our parachute out right at the very top, right at the apogee point. So now it's not showing us the thrust to weight ratio, but we can see that if we right click on this top row, just right click anywhere and it will bring up a little menu that says organize columns. So select that. And then it will give us a list of things that we can plot here in this chart. And one of them is thrust to weight ratio. Where am I looking? There it is. Thrust to weight ratio at launch guide departure. Oops, I turned it on and I turned it off. And I'm also going to select velocity at launch guide departure. And I'm going to turn off simulation number, engine diameter. Yeah, click OK. All right, so our rocket one should still be down here at the very bottom. And so now we have two new columns, thrust to weight ratio at launch guide departure and velocity at launch guide departure. Okay, so here is that thrust to weight ratio that you were talking about. You said my thrust to weight ratio should be greater than 5. And here we're at 10. So this rocket obviously has a thrust to weight ratio greater than 5, which is good. Personally, I like to use velocity at launch guide departure, this number right here. And I want to see that number above 30 miles an hour. And I like that better than thrust to weight ratio because, and the reason is thrust to weight ratio, when you look at that number, is like, what thrust are you talking about? Because the rocket motor's thrust varies over the burn time. And, on some rockets, you might, when it first ignites, it may have high thrust. And then on some rockets, it might have a low thrust and then gradually increase over time. You looking at the number on the rocket motor case, you don't know. So we calculate the thrust to weight ratio at launch guide departure because I want to know what's the thrust level when it leaves the pad, not when it first ignites, which is before it leaves the pad, but right when it leaves the pad. So that's why we say thrust to weight ratio at launch guide departure. Most people don't think that deep. They just want to see thrust to weight ratio greater than 5. This is 10, so this one's fine. So let's choose. Let's see if we can get a lower motor that has a lower thrust. So I'm going to go choose an engine. Here's an H73. Let me sort this by engine. H73. Okay, here's an H45. And I know that this has a low thrust. And so now we're going to say we need custom ejection delay because it doesn't. This is a plugged motor. Let's call it 5 seconds and use that. Click OK, and then click launch. So the only thing we went from an H130 to an H45, and then we click launch, and we'll do a comparison. So now, here's our H130, here's the H45, and if we look over here at the thrust to weight ratio, we're at 3.46 when it leaves the launch pad. So under your conditions, you would never fly this motor. But I like to look at this number here. And then what I really want to look at is what does the flight really look like? Because these are just numbers, and sometimes numbers they don't mean anything. So let's make sense of the numbers by putting a picture to it. And to do that, we're going to come up here to this trajectory button and click on that. And in 2 seconds, it's going to load our flight visualizer. And the flight visualizer is going to give us why did it do that? Come on, your temporary expires in 30 days. Close. Okay, I had to click the close button. So what it's doing now is it's loading the launch visualizer. And this is going to give us a video of the rocket's flight. So right now, we're at the Huntsville area launch site. And I'm zooming out so you can kind of get the lay of the land of where this rocket launch is occurring from. And north, this little compass down here. North is the black arrow. So if I swing it to the top, that's north. And somewhere like right in the middle of the screen is our launch pad. So I'm zooming in, zooming in, zooming in, zooming in. There it is. There's our rocket sitting on the launch pad. And you keep zooming in. So now you can see the rocket sitting on the pad. Okay, so I'm just kind of reorienting things here. So we're kind of looking at it from the side view. So you can see our rocket. And you see this cone right here. This is called the weathercocking cone. And this is one of the criteria that I use to determine if the rocket motor selected is good enough for the flight. What I want to see is I want to see this rocket stay inside the cone until it reaches apogee. So the apogee point is inside this cone. And if I keep zooming out, the cone will stop somewhere. And it will kind of give us an indication of how high the rocket's going to go. So you can kind of see right here the top of the cone. That's how high this rocket's going to go, because RockSim's already knows. And if I click launch, you can see the rocket's taking off, and it's kind of going straight. It's staying in the cone. And I want to know if that apogee point is inside the cone. And yes, it is, because it put a little dot. That dot is the apogee point. And now the rocket is drifting back down to the ground. And okay, so there's where it landed. I'm trying to think, is this a lake or is this just kind of like a flooded area? It's hard to tell. I think it's just kind of like the floodplain. I don't think there's any water in there currently because this is a field. But I can see the trajectory, and what interests me about this is the rocket stayed pretty straight, even though it was a low thrust motor. So based on this, there is the possibility that if you're willing to risk it, that the rocket will still go straight with that particular rocket motor. So even though its thrust to weight ratio is not quite 5, the trajectory looks still pretty straight. Now the question is, do you trust it? And that I can't answer because that's something that you have to determine yourself. But hopefully that explains thrust to weight ratio for you. DK says, I'm just getting back into model rocketry after 30-ish year hiatus. Yay! Welcome back. We've been waiting for you. Building a big rocket now to refamiliarize myself with how to do it. That's good. Curtis Howe says, hello from Michigan. Friar Pablo says, welcome back, DK. And he also says, thanks, Tim. Much appreciated. DK says, Wheelox World, yes, but I'm talking about my custom design. Friar Pablo says, how does your custom design differ from the Estes design? And I don't know. Friar says, I'm not altering the Big Bertha, designing something totally different. And Alfred Indy retracted his message. Friar Pablo says, okay, hope it goes well. Wheelox World says, is RockSim ever going to be able to simulate thrust vector control and repulsive landing? Repulsive landing? No. I can tell you that one, no, because it can't do it. I mean, because then what we need, RockSim assumes that when you have thrust, it's pushing in one direction towards the nose cone, towards the top of the rocket, or towards up. When the rocket's coming down, the thrust is also assumed to be pointing towards the nose cone. So it's just ramming your rocket right into the ground. We would need a rocket motor that had thrust in the opposite direction. So a negative thrust rocket motor. If there was such a thing, theoretically it would work, but I do not believe you can make a rocket motor that has negative thrust. We could try, but the other one is simulating thrust vector control. And we can simulate vectored thrust, but we can't control it. For example, so you can only do this in RockSim Pro. RockSim Pro does allow you to change the orientation of the thrust. And so imagine it like a V2 rocket. You know, in the 1940s, when the V2 came out, they controlled the thrust by putting deflection vanes in the thrust column, or in the exhaust. So they put thrust vector control there. So they're not moving the motor, they're moving the exhaust by these vanes. And that's what we can do in RockSim Pro. So to do that, you come over here to prepare for launch. And then on this screen right here, we have an error axis degrees. Okay, so error axis number 1 is how many degrees off of the center line the thrust is. So I can say 10 degrees off the center line. And then error axis number 2 is kind of like, again, it's the compass direction. Which direction is that thrust pointing? You know, is it to the north, to the south, to the east, to the west? So let's say I'm pointing that thrust 90 degrees, which I think is to the north. So as the rocket takes off, we expect it to curve towards the south. So if we look at the flight profile, again, I'm not changing anything else. I'm just changing the thrust direction. Get away here for this and then close that. And now it's going to load the launch visualizer. Let me put this up here. And look at the time here. So before we were at like 58 seconds, and now we're at 5.44 seconds. And we can see that something happened here. The last time we went 1,400 feet. This time we only went 98. So, oops, I didn't want to do that. I just want to make this screen a little bit bigger. And zoom out. And let's launch it. So, see, by vectoring the thrust, we crashed. You can see the rocket's flipping end over end. Yeah. So north is straight up. And remember, we have wind also coming from the west, blowing this rocket around. All right, so, okay, so that is vectored thrust, but we can't control it. We can only set it at one angle, and that doesn't help us. The whole purpose of the thrust vector control is so that you can control it and keep your rocket going in a direction that you want it to go. Usually just straight up. But our rockets are not guided. So not only do you need thrust vector control, but you also need a flight computer to control which direction it's going. And you can do it. There are companies that make thrust vector control equipment, but we can't simulate it. The other question is, can we simulate a negative thrust motor? And I don't know the answer. I don't think it's possible, but we can check. So to check it, we're going to open up another program that comes bundled with RockSim, and that's called Engine Edit. So I am looking for my program right here called Engine Edit, and I'm going to open that up, and it says this was from the internet. Okay, so to create, so basically this is creating a new motor. And we're going to say add a new motor, and we need to give it a burn time. Let's call it 3 seconds, and a peak thrust. And so here's where we're going to find out. Can we use a negative number, minus 15 newtons, and click OK? You know what? I think it worked. Okay, so then, nope, maybe it didn't. The thrust curve has no burn time or peak thrust range specified. Change the engine burn time and peak thrust, and then push the set new graph limits. Okay, so burn time, we said 3 seconds. Can we change it here? It's not letting me change it here. Yeah, because I don't think it's allowing me to have a negative thrust. Let's go 3 seconds, new peak thrust of 1 Newton. Click OK. Yeah, and I'm trying to drag it below the 0. See, there's my, this is a thrust curve. So it burns for 3 seconds and it has a peak thrust of like 0.8 newtons. And so it has a total impulse of 1.2, which is like a quarter A motor. And you can bring it down. And I want to see if I can drag this below. It still didn't let me drag it below. See, I'm trying to drag. See, here's 0 thrust. And to have a negative, I need that thrust curve to be below the axis. But it keeps putting it above the axis. So it's not going to let me. So without, let me try one more thing. Let's go up here to view time ordered data. So we have thrust of 0. We have a thrust point, which is this one right here at 0.086 newtons. Let's see if I can change it to a negative minus point. Let's minus 5. And hit tab. And then close it. Oh, look at that. I think I have a negative thrust curve. Let's save it. So manufacturer, let's call it Wheelock. Spell your name, W-H-E. And the engine code, oh man. It's got a negative total impulse. It's a total impulse of 7. So that's a C. So this is a C minus 2.5. Engine type, let's make it single use. Delay 0. 3 and 4. Diameter, let's make it 18 millimeters in diameter, 2.75 inches long. And give it an initial mass. I'm just seeing if I think it's possible. I'm getting a spinny ball, which is not a good thing. Why is it giving me the spinny ball? Kind of froze up. It froze on me. Force quit. Yeah, it says Engine Edit Pro is not responding. It didn't like that. Force quit. Yeah, I'm just going to lose everything. Force quit. So I still don't know the answer to my question if I can make a negative thrust motor. But that would be the technique, is you have to go into thrust curve and create a negative thrust motor. You're making me think, Terry. DK says, this class alone is worth the price of RockSim. I'm glad you said that, because I agree. Okay, that's all the questions I have. We still got like 6 minutes left. Any other questions going on in your mind? Yeah. Nobody has a question? I was like, okay. What are we working on here at the Rocket Ranch? Well, so one of the things you saw was this screen right here. So when we do a launch, we're gonna, this is coming soon, and we're basically testing this out. Is to make RockSim Pro ad supported, which means that it doesn't cost you anything, but we're going to sell ads on the back end and we're going to advertise towards you. So you're going to get a screen that pops up and you're going to have to close it out. I know that's annoying, but we're going to give it a try because I really want you to get guys to use RockSim Pro because it's like so much better than anything else. So what I've been working on here recently was creating all these ads. Just advertise. I haven't sold any ads to anybody else, so right now they're going to be Apogee ads, and I'm trying to make as many as I can so that they pop up and so you can see them. So, for example, at Apogee, you get guaranteed same-day shipping to the carrier. So basically, that means we get it out the door the same day. We can't control the courier. We can't control how fast they get it to you. We can control how fast we get it to them. And we guarantee the same-day shipping. So that's that. That's kind of like what we're working on, and it's getting pretty close. So hopefully we'll be announcing it when it's available pretty soon. Yeah. Showing one more message down here at the bottom. We have Space is Cool says, hey, Tim. Well, what's your question? What else we got? What else? Yeah. I really love the 3D launch visualizer. It's just so cool. Please select at least one simulation. The 3D launch visualizer is like what makes RockSim Pro so unique. Because you can look at the rocket from different angles. I can even look as like a camera on board the rocket. So this is looking down at the launch pad and the rocket takes off and you see all that thrust and all the smoke. That's what's going on there. And eventually it'll burn out. And now I'm looking at the sky because the rocket's arced over and eventually I'm back down on the ground. Or I can look at it from the view of a person on the ground. And you can see the rocket's taking off. This view right here is called the mini view. And what the view we're looking at right now is the rocket's, our viewpoint is below the ground. That's why we're not seeing it. We're under a mountain. And I can't control where the viewpoint is. The viewpoint is usually always to the north of where the rocket is. And I think my rocket's down in there somewhere. Yeah. This was the rocket that went unstable. No, didn't. It was in the air for 16 seconds. What motor did I use? An H-45. This one must not have had a, I don't know why it's gone straight. All right. Space is Cool says, I'm just here to watch. Okay, well, thanks for coming. Yeah, we're at the end of the day. And why is this camera not working there? That camera's not working either. So that's the end of the today. Next week is, I think it's Friday the 3rd of October. And I will not be here the 3rd of October. I have to go out of town. But I will be back the following week. So I believe that would be like October 10, somewhere in that area. Again, it's going to be the Friday at 4 p.m. Eastern Time and or 2 p.m. Mountain Time. Or it's kind of like 10 p.m. in the Netherlands. Yeah, so hopefully by then we'll have the big announcement on RockSim Pro when it's available for everybody. But until then, you have to wait, or you can get on our newsletter subscription list. I would always suggest that anyway. If you go to our homepage, right here, there's a big blue banner that says sign up. And once you're on our newsletter, we're going to send you 50 free rocket plans. But also every week, we're going to send you either a newsletter or a video. And when we send those out, we also have new product announcements in there. So that's kind of like the first place that we announce anything. So our newsletter subscribers get that first. And if you want to get that, be sure to subscribe to that newsletter. And you could also might subscribe to our YouTube channel. That doesn't hurt either. But we don't make announcements on the YouTube channel. That's just for posting videos like this one. All right, so thank you for coming. And I'm going to give you a countdown and a launch, and then we'll get out of here. So in 5, 4, 3, 2.